Hello and welcome to this video in the R course. In this video, we will be learning two important concepts in R. One being UDF, that is the user defined function, and the second one being MLE, that is a maximum likelihood estimator. Now what is UDF? UDF is basically a feature in R in which the user can create a function that he or she designs or defines herself or himself. So it is not a pre-installed function that is there in R. Instead, it is a function that the user designs himself or herself and then uses that function for further application. All right. Not all functions might be there that you would want to use in R. Hence, there might be certain scenarios where you would want to make some tailor-made functions for your further use. Let us try and understand how these functions are created. We take an example over here where we are trying to make a function which will help us scale down or scale the values so that the impact of units is removed from it. Alright, so it's basically a function used for scaling. The function that we want to create is called normalize. Alright, this is the name of the function that we want. So we will normalize the values in a given vector using this function. Whenever you want to create a function, you should be able to, in your head, create a stepwise bifurcation of what you want the function to do so that you can allocate those steps in a chronological order in order to get a sensible output from the input. Alright. So in the normalize function, what we want is that whatever vector we give, it should be subtracted from the minimum value of that vector, and then it should then be subtracted, there should be a numerator which should be max of that vector minus the minimum of that vector. This is what we want the function to do for us. So each and every value in the vector will be first subtracted from the minimum value of the vector and then divided by the difference between the maximum and the minimum value of the vector. Clear? So this is what the function will do. So now I will break it down into steps in order for you to be able to create this normalized function, and then we will implement this function on a given vector. Clear? So step 1. In step 1, we create the numerator of the function, which is this. The numerator of the function, which is this. So numerator is equal to x minus minimum of x. Now what this x will be, we will design later on. Alright. Similarly, denominator is equal to max minus minimum of x. So now we have the numerator and the denominator. Hence, to normalize it, we need to simply put numerator divided by the denominator. Numerator divided by the denominator, which is the normalized part. Clear? So step 4 is to print the normalized value, which is this. Clear? So now I am going to put all these steps together in one function, which will be my user defined function. So first things first, we need to give the name of the function. I name my function normalize. Fine, I name my function normalize. You can use any name, but it should not be a reserved word in R. Then we start to create a function. The keyword is function. To create a function, the keyword is function. We then open the brackets. In these brackets, we pass the arguments that we want from the user so that this function can actually work. Alright. So here we need only the vector argument from the user. So I write x. So you pass the x vector in this function, and the function will automatically normalize that vector. Then we start curly brackets, and in these curly brackets, we will write down the steps that the function should perform for us. So first, the moment the user inserts this vector value, in the back end, R will calculate the numerator by this formula. Then it will calculate the denominator by this formula. Fine. Then it will normalize it by doing numerator upon denominator. And finally, the output that we want will be printed since I have written normalize over here. It's very important for us to write normalize over here, because if we do not write normalize, all the things will be calculated, but there will be no output in the console. So it is important for us to make sure that whatever we need as the output in the console from the function, we should give that in the end so that that amount is printed. Clear? So what we do is we simply take these values and execute this command. The moment I execute this command, you see there's a function that is created called normalize, and it has just one argument. Hence, you have to insert just one argument in this vector. Let us now try and implement this function. Clear? So I create a vector x and then I write normalize x. And you can see that the normalized values of x are in front of us, which is simply x minus minimum of x divided by maximum minus minimum of x. We can try it with some other vector also. You can see if I write 1 to say 100 and then I write normalize y, it will do that for me also. Clear? So this is how this function works, that you create a user defined function based on the requirement of the user, the need at that point, the need of the user, the objective that the user has to meet using that particular functionality. Clear? We will see another example, and in that example we will learn how to create another function, and at the same time we will maximize that function based on a particular variable to find out the maximum likelihood estimator in that function. Clear? So the case at hand, or the example that we are looking at, is that we have a data set where we have the speed of cars and the number of cars measured. We now want to model the number of cars per hour, which is x. Clear? We assume x follows Poisson distribution with an unknown parameter lambda. Clear? The log likelihood function for estimating lambda is log L is equal to log of lambda into sum of number of cars minus lambda into number of observations. Clear? First part of our question is plot the likelihood function, this one, log L, plot the likelihood function for values of lambda ranging from 220 to 280. Second part is determine the maximum likelihood estimate of lambda. Clear? So in the first part, we have to first create this user defined function log L and plot that against the values of lambda prescribed, that is 220 to 280. And in the second part, we have to find out the maximum likelihood of lambda for this function log L. Clear? So let's see. The data at hand is this. We have an Excel file which we import using the read Excel package. All right. Let me show you the data. The data looks like this. You have number of cars and the speed of car. Okay. And we have 232 observations. You can see here also and here also. All right. I'll clear this for you for now. And we start. So, all right. Now, first things first, we have to create the function log L. See, it's a user defined function. It is not there in R from beginning. So we need to create this function. So to create this function, I write log L. This is going to be the name of my function, log L. And we start with the keyword function. Obviously, this function has only one argument, which is lambda. It has only one argument, which is lambda. So I write lambda, which is going to be inserted as and when we use this function. And then we start with the curly brackets, which is where the body of the function will come in. So we write L, we create a variable L and we assign this value to it, log lambda minus sum of, as you can see, sum of number of cars, which is cars.data dollar number of cars. The first column in cars.data data frame, the first column you can see here, the first column number of cars we have picked up. So this will be the sum of number of cars minus lambda of length of cars dot data. Why? Because we need to find out the number of observations in this. We know that it is 232, but instead of writing 232 over here, I want to make it completely dynamic. I want to make it completely variable so that tomorrow when we use some other data set which has some other number of observations, the length function will pick up exactly the key number of observations that are there instead of writing 232. Clear? So whatever is calculated over here is saved in a variable L, and then as I said, whatever I want to print, I'll put it in the end of the function, which is L. So the moment I execute the log L functionality and then pass the arguments in it, it will give me the values in the console. Clear? So if you go back to the question, you saw that it had asked us to plot the likelihood function against the values of lambda ranging from 220 to 280. So I create a vector where I have values for lambda 220 to 280, and now I pass these values in the log L function. Clear? And then you can see different values of lambda give you different values of log L based on the function that we had created. And if I plot lambda and log L on here, that is lambda on the x-axis, log L on the y-axis, you can see that this is the kind of plot we can see. Just by looking at the plot, you can see that the maxima is somewhere between 250 and 260. Obviously, that this is just an estimate between 250 and 260 looking at the graph. It is not an exact estimate. For an exact estimate, we need to calculate the maximum likelihood estimator. Fine. We need to calculate the maximum likelihood estimator. For that, we have a function called NLM. NLM is a function that is there in R present for us. What this function does is that it minimizes any sort of function that you put in NLM. So you can see here, this function carries out a minimization of the function f using the Newton type algorithm. So basically, one of the arguments in the NLM function will be the function which we need to minimize. All right. And then it will give us the value for which that function can be minimized. Now the problem here is that the NLM function minimizes. However, we want to find the function that maximizes since we want the maximum likelihood estimator. So what we can do is the function that NLM minimizes, if we take negative of that function, and minimize that, then automatically we are maximizing the actual function. I'll repeat it for you guys. NLM function basically minimizes whatever function you pass through it. But for maximum likelihood estimator, we need to maximize the function. So what we do is we take the function, we find the negative of that function and minimize it. Minimizing the negative of the function is similar to maximizing the function. Alright, so we create a new function called n log L, that is negative of log L, and we write that is equal to function x and within brackets simply minus log x, that is negative of log L x. Negative of log L x, and we create this function. And now in the NLM we have to pass two arguments. First argument is the function we want to minimize, which is n log L. Remember, if we minimize n log L, we are in effect maximizing log L, alright, which is what we want. So in the NLM function we have two arguments. One is the function we want to function to minimize. And the second argument is basically we are giving a starting point for R to run its iterations on, after which it will tell us at which value this function is minimized. Clear? So we give 250 as the value because if you remember when we saw the graph and we saw that 250 is pretty close to the maxima of this function. So we say that use the NLM function to minimize n log L and start with the value of 250. And the moment we execute this, you can see here that R has given us the output that your minimum value is minus 267,846.8 and it occurs at the value 254.3662. It had to run only 3 iterations to do this. You can see that the gradient here is 0, which is expected at the maxima level. Clear? So our MLE estimate is 254.3662. 254.3662. You can see here when we had run this also, you can see 220, and you can see, yeah, over here it increases and after this point it will start falling. See, after 267,846.6 it has started falling again, and when we run this you can see that the value is also 267,846.8. So NLM function helps us find out the MLE in R, which basically uses negative of the likelihood function, because NLM minimizes the function that you pass through it, and negative of the likelihood function, if we are minimizing that, we are in effect maximizing the likelihood function. Clear? So to use the NLM function, we have to be very careful. We have to first create a user defined function which is going to represent our log likelihood function. Then we take the negative of that log likelihood function and minimize that using the NLM functionality. We need to give a starting point to R to run its iterations. To do that, we can make use of data visualization, where we can plot a graph which will help us figure out that in which range are we going to expect the particular function to get its maximum value. Clear? This is it for now. Thank you.